Morning, everybody. My name is Jarrell Carson, and today we will be discussing audio devices and audio files. Today we are going to cover some of the common devices that were used and how they were discovered in their generation, and we'll also go into more details about each device and comparing their features and functionalities. And we'll also finally discuss some of the latest audio files, what their functions are and how they're different from one another, and where they come from, like where they're manufactured and provided in our generation throughout this time period today. So other than that, let's get started. So you might be asking, what is audio? Audio, or sound, as people like to call it, is a terminology that we use to describe any source of frequency or noise that is within a range of the human ear is capable of hearing. So I might have to ask you all, how much can a human's frequency can we hear? Like how far can we hear? Does anybody know? Yes, Ben?
From 5 hertz up to about 10,000-ish.
You're pretty close. Anybody else have a guess? Okay. A human's hearing can have a frequency from 20 to 20,000 hertz. So it's kind of like an example, if you can probably hear a whisper, like you can go from a whisper to probably a huge explosion. That's probably how our frequency range would be, and that's how much we can have our capability of hearing. So I'm going to take it to another level. How about a dog's hearing? Can anybody tell me how much a dog can hear? Any guesses? Ben?
Up to 45,000 hertz.
45,000? Anybody else? A dog can pretty much have double the amount, or triple, as we should say, about 40 to 60,000 hertz. So pretty much they can hear the little tiniest microscopic thing up to, like I said, an explosion, or it could be some kind of siren. It could be anything that has a really high frequency, and it can be a really, really low frequency. So pretty much we have two different kinds of frequency, and the reason why a dog can hear more than us is because of the fact that they have stronger muscle tones in their bones and their ears than we do. So that's why they have the capability of hearing better than we can. So for another example, for computers and other multimedia devices, they all are measured in hertz. Which a hertz for computers is also measured in a unit of frequency range for 1 cycle per second. And the audio signal is generated through integrated sound cards that might be on motherboard, or you might be able to upgrade or buy one from a regional store, or you can probably get one online, just depending on how your device is designed and how you want to customize it. So some examples of some common audio devices that we have today, as you can see from this display that I have down here. They can have speakers, headphones, radios, microphones, anything that has some sort of audio inside of it. So any sort of information being stored or played back in a computer is also known as an audio or sound file. So here are just some examples of some audio file formats that you may have. So like the MP3, the wave sound, MWA, which is Windows Media, AAC, OGG, and MIDI. So now we will be talking about 4 different types of generations of sound recording and reproduction. The first one we will be going over is the Acoustic Era. The Acoustic Era started about 200 years ago, probably in the late 1800s, when we were discovered by a man named Edward William Scott de Martinville. And I have to honestly say, without this guy right here, we wouldn't even have audio today. Like, we wouldn't understand what audio came from. We wouldn't understand like what the functionality behind audio was, or how it was even discovered even at all. So like no music, no radio, speakers, cell phones, any of that had audio, it would not be here today if it wasn't for this guy. So I give all the credibility to him. In about the mid-1800s, the phonograph was created, which was the first audio device that was ever made. And it was also had the ability to be able to use this for audio recording and experimentation, and that's what he used this device for. So Scott theorized that if he built the first audio device, he could use this to benefit his studies, be able to kind of discover the great asset behind audio for the future. And he also, the only flaw that he had for this device was the fact that when he created it, he forgot the fact that it couldn't play back to him. So when he was trying to record a note, or he was trying to record some kind of theory that he was trying to come up with for his experiment, he couldn't hear himself while he was trying to record. So although his device was meant for recording, he could use it for profiting and also selling it to the public, but he decided he didn't want to do that because he just felt like it was more personal and it was more beneficial to him rather than the public eye could see. So this is what the device looks like. As you can see, there are some label parts here showing how each part of the device is functionized and how it works. So you can see there's a reel on it from the back, so when he's winding it up while he's recording, that's how it would work. And paper material, which is called lamp black paper, or you can also call it just oil paper, was used to be able to kind of catch the frequency while he's recording. And by using the lamp fill paper on the cylinder drum, which he records his thought, and note the frequency of his voice was very inaccurate and less precise because it was not really the best sort of material that he could use for this device, but he used it anyway to be able to just kind of get a glimpse of what it would be to record and make notes of. And the only way it would work, like I said, you would have to take the handle, which is in the very back, and you have to kind of put a little bit of pressure on it because, you know, the paper was very thick, it was very complicated to be able to turn. So he had to put a lot of force and a lot of pressure in order to make it work while he was trying to record. So now in this video, I'm going to be showing you kind of some stages of the voice frequency and how it was able to kind of show a little bit of restoration as it goes along, and you'll see it. Okay, so as you can see after watching that, the device obviously didn't have good quality back in the day, but each time you could hear the audio frequency getting better and better as it was being readjusted, so he wanted to test it just to make sure it was working properly. And as you can see, again, it was working, but again, it didn't have as much quality as you think it would. It was very awful. It did have poor quality in their time period. So, does anybody have any questions, any comments, concerns? Okay, so now we will be going over this, another man that you guys might understand and recognize from a very historic point in time. His name was Thomas Edison. Does anybody know what kind of famous invention he made? Yes, Daniel.
The light bulb.
Okay, the light bulb, that's a very good one. Very famous and still popular to this day. Does anybody else know another invention they might have made? Okay. Thomas Edison, as you can see, he was a very intelligent and brilliant scientist during his time and did develop a lot of successful inventions like the light bulb. And one of his most famous inventions as well, other than the light bulb, was the phonograph. The phonograph was invented in 1877, which again, it was still during the mid and late 18th century. And he invented it so it could be able to record sound and play audio, just like the last one. The only thing was Edison was able to discover how to be able to record and have it play back to him as he was being able to use the audio. So, as Edison believed that his device should be created for business and communication and corporate industries, he then discovered afterward that it would have been better to make it more profitable for more entertainment-wise. So he felt like maybe the radio business, the music business, or any sort of entertainment resource like that would have been helpful to use for this device. So having to put a lot of thought and effort and dedication towards investing in this device, the phonograph became one of the most historic audio devices in their time period. So during this time of the origin in 1928, the phonograph itself had about over 800,000 devices sold worldwide and made over 48 million cylinder recordings, because how it worked for his device, it only could be able to record a certain amount before the paper and the material would be worn out and torn up. Because how they would use the device, they would install these little needles inside, and it would kind of like scratch the paper as he was winding to be able to kind of set recording frequency. So this is the phonograph and what it looks like. So the only difference was, just like I said, Scott designed the first one, but it didn't have the playback feature. But Thomas Edison also installed not one but two cylinder drums that you can see from this side and the other side of the big cylinder drum. So he put smaller cylinder drums on the front and the back so it can be able to input the audio and outcome the playback. So, like I said, he wanted to use this more for entertainment. He felt like it would have been more profitable, been more interesting, rather than what Scott said, for more experimentation and more personal benefits. So, I want to show you guys for this video, it's going to be a video about how the phonograph was designed, some of the tools and resources that he had to use in order to kind of readjust and kind of upgrade the phonograph to be able to still constantly be used. So,
some of the early machines were very crude. This is a Berliner Volkswagen that first saw the light of day in 1870. These are the earpieces. That bomb-shaped thing in the middle is the distribution center, and this the intricate machinery for sharpening the needles. An Edison machine, hand-worked and filled with governor. Another old vintage horn and cylinder model driven by clockwork. Patte came along with a machine that employed a sapphire needle. A weight propelled yet another type of early sound-reproducing machine, and with this one, small wax cylinder records were used. The original sound box, paper and pin. These diagrams will show how the sound is picked up and distributed. The old Hill and Dale groove, which is now being revived. present day system with a lateral or sideways movement.
Does anyone have any questions or comments about this device? Okay, so let's proceed. So as you can see, each device had their own flaws and errors, but they began progressing over time and adapting toward the environment. So that way, when we know what we expect for the next trip and what to expect for the next device, it will be better than the last one. More scientists, more technicians are emerging and starting to come about because the world needs to become more technological and we need to adapt. Because as you see, technology today is still constantly being adaptable, keep being more advanced and evolutionized so we can be able to discover more and be able to use more for our personal benefit and interest. So I want to discuss another brilliant scientist who not only kept prolonging the audio technology, but he extended his knowledge and preferences toward developing another type of audio device, and his name was Emily Bergman. So this is a picture of him and what he looked like. And he continued his study. He was more, I wouldn't say he was more like a scientist. He was more like a inspirational kind of person because he kind of looked up toward Thomas Edison and Alexander Graham Bell and some of the other historic scientists that were out there. So he wanted to not really like the way he developed his own kind of device, but kind of preset and update older devices so they can look and sound better. So he continued, like I said, to invest in a metal conductive transmitter that produced a strong receiver for the phonograph. That was one thing he did. And the other thing that he created was the gramophone, which was kind of like a record player, as you can see, but what he designed on it was he designed not only the vinyl disc, as you can see down there, I have a set that he designed, but he also kind of to install needles. He designed the horn that would put onto the record player so it could be able to project more, and also through his many trials and errors that he developed during making this device, he also attempted making various tests using the periodic table and using different elements to kind of replace the substance for zinc that was used on the vinyl disc. The sound that was recorded was on a groove, as you can see, and what the groove is on this picture is where the needle goes, and that's how it creates a circular motion onto the recording device. And it goes in a particular spiral motion, and on the outside of the disc in the center, the gramophone plays the sound and on the needle that touches the groove. So like I said, on this picture it showed how the needle is being placed on the groove and being able to play on the vinyl disc in order to record sound. But before he created this device, he wanted to kind of go back to stock device, which was the phonograph, and be able to test upon research to see if he could be able to develop anything for his device as well. But unfortunately, he couldn't be able to, because again, the device wasn't really as popular, it wasn't really as discoverable as Edison's device was. So in the process where he was coating the zinc disc onto the vinyl disc, he would be able to immerse the disc in an acid bath. After it dried, the record would be flipped around so it could be able to do the same process, so it could be coated on both sides. So he could be able to play different sounds on both sides. And coating the black reverse side of the disc with varnish, he could immerse the disc and be able to do the process over and over and over just to make multiple of these, not just for just one particular disc. And each of the discs would play different sounds on multiple discs. So after we have discussed that, we can go into this video, which shows a basic evolution of showing all different devices that were shown out in the Acoustic Era time period.
nothing more than a valuable antique, but when this phonograph first hit the market in 1904, it and the phonographs that preceded it were part of a minor miracle. These things, with their wax cylinder recordings, altered forever the way human beings enjoyed themselves. For the first time, music was available at will in the house to those not rich enough to support a private orchestra. The first recording ever made was of these words. That was in 1887. The speaker was Thomas Edison himself. Florence Nightingale, describing the Battle of Bad followed, so did many other recordings of music and poetry. Tennyson, reading selections from Maud, was very popular around 1890. But cylinders were eventually replaced by flat recordings. This is the Edison Diamond Disc of 1889. Bakelite and shellac, fragile, heavy, and very, very thick. As 78s progressed, they lost a bit of weight. As the records changed, so of course did the players. This is the Ramshorn player, obvious where it got its name. The sound is taken mechanically down here and then travels acoustically up the tube and out of the horn, no amplifiers or electronics there. Sometimes these ones came with bamboo needles that had to be sharpened after every single record. By the 1920s, this was the height of elegance. It had metal needles, literally needles, very sharp indeed, and a very heavy head. It also had to be wound mechanically.
Okay, so does anybody have any questions so far? Any comments, concerns about the acoustic? Okay. All right, so let's keep talking about the next time period, which is called the electrical era. The electrical era was between the 1925 and 1945, where technology became more recognized and that audio technology was beginning to change. Edward Wendt was introduced by inventing the first additional condenser microphone, which I have an example down here on the bottom. It's just a different and more modified version. But he wanted to become inspired as well, just like our previous inventor, by Thomas Edison, Alexander Graham Bell, Emily Berliner, and others have created their own source and format of the condenser microphone. So in this picture, it shows a diagram of the microphone itself and how it was developed and created, and it kind of showed different parts and labels for it and how it was functionalized for each part. So with this condenser, the original frequency had a range of 250 to 2500 hertz to about 500 to 6000 hertz, which was a huge gap, but it also increased the amount of frequency and volume that it had in the microphone itself. And given towards the microphone itself as well, it had the ability to reduce the amount of harmonic distortion and gave it more of a sound imaging quality. And this is a picture of a vinyl disc that was used back in the 1920s, and these two developers named Edward Kellogg and Chester Rice, who were in two different companies that were called the Bell Telephone Laboratories and the Western Electric Company. And they were two very distinct companies that worked together to perform and create a device called the Vitaphone, which is basically a device that was used for a disc-on sound system. So they would kind of use like the record player, so they put the vinyl disc on there to create the sound. And they also created this device to promote picture for the very first time. And they also, later on in the mid-20s, developed a device called the loudspeaker. And the loudspeaker was one of these first projective audio devices that was ever made. And it also had a very lightweight paper material that was put around the horn to be able to have it lightweight. So like if it was hanging in the corner, or if it's hanging and installed on a table or something, it would prevent itself from falling, because it was a very heavy device, but at the same time, it would prevent itself from being too heavy and tipping over. They also attached a coil wire around it to be able to have a very large magnetic structure. So again, it would prevent itself from falling over, or if you were installing it on a wall or something. Rice and Kellogg also wanted to install the device so they could design an amplifier so it could be able to have adequate sound and volume towards the speaker. But not only that, it was super critical that the amplifier would be recognized so it could be in the market, and it could also be self-profitable for entertainment-wise, for radio production, and all sorts of that good stuff. And now we can go into the magnetic era, which was between 1945 and 1975, which was a periodic time period where audio devices were becoming more effective, it was becoming more technological and advanced, and being able to record devices onto not more like records, but it's more like winding material, and things were starting to turn more digital, but just not yet. Like we're getting there. So magnetic tape was this man right here, by the name Fritz Plumer, I think it's how you pronounce his name, was a German scientist back in the early 30s who developed the very first magnetic recording device, and basically he used it to be able to show how this technology worked for the Germans during World War II, to be able to kind of seek what the Americans and the others during the war were planning, what they were scheming, and how they could be able to listen in. But later on, we found out that we wanted to discover our own version of the magnetic tape recorder. So we designed, during the mid-50s, the UNIVAC 1 computer that will be able to develop our very first recording tapes called Universal 1 tapes. So the magnetic tape was the medium source made of thin magnetic coating of plastic film that was around the circular cone. And basically it would be able to pre-record audio and have quality that was far more effective than the disc itself. And later on we found out that the vinyl disc was starting to become off the lease. So we wouldn't be able to sell or profit it because of the magnetic tape just starting to become more popular and recognizable. So in this video, we will basically be kind of just showing a demonstration of how magnetic tape worked and what the material was made of and what it was used for.
So what is in magnetic tape? The answer might surprise you. It's rust. That's why it's brown. Magnetic tape is made of a plastic film backing that has a coating of iron oxide powder on one side. Iron oxide is literally rust, as it's the result of the oxidation of iron. Iron oxide is easy to magnetize, so it became the obvious choice for making tape. By using a fine powder, magnetic tape was able to run at much slower speeds than wire. This was because the fine particles are magnetized individually, and thus you could get changes in magnetization closer together on the tape. This was important for high-frequency signals, which need to alter the magnetic field on the tape very rapidly. With wire, it couldn't get too close together, so the wire had to run at the very fast 24 inches per second. But tape only needs to go at 7.5 or even 3 3/4 inches per second to get the same quality of sound. Let's go into that a little deeper.
So, as he was saying, the recording ranges were increasing rapidly and being able to extend their connection over time. And with the sound on the tape, it was able to be easier to edit and mix, because back in the day, they didn't have that type of technology where you could edit and record the sound that you needed. So with the magnetic tape material, you could be able to kind of go back and look over what you could edit and fix during that time. Magnetic tape could also be used for data, and it was able to produce over 48,000 bits of information at a time, which made computers faster and more productive. So continuing forward, we were going to see an inventor who created his own sort of tape recorder device. But we also need to look at the fact that after Fritz created his own, and then we came in later to design our own sort of magnetic tape material, we came across the very first cassette tape recorder, which this was designed and developed by Philips, if anybody remembers, that was a very popular company back in the early 50s and mid 50s. And the cassette tape came in various forms, so basically each of them had their own specifications and qualities towards the tape. So there were 4 types. There was a type 0, which was a ferric optic, a chrome, and a metal. And sound quality, each tape improved each time they were developed, and tapes were providing the best sound quality. All right, the last one we're going to go over is the digital era, but I'm going to kind of cut it short and just kind of simplify what digital era was about, which was from the mid-70s to present time. So after the magnetic era came to a closing end, we were introduced to a company named Sony, which was a digital audio company that was first created to make digital sound encoding, which allowed devices to convert from sound sample to digital binary numbers. This device here was the first device that was called a Sony PCM-1 audio digital recorder, and this device had the capability of showing audio components that were connected to home VCR systems and digital recording audio tracks. And digitizing electrical audio signals consists of first sampling over 1,000 times per second, measuring the amplitude of each sample and assisting one of a limited number of binary values. A man named James Russell came along after that device was created and made the very first CD, which was made in the early 80s, and came along later on that James wanted to work with Philips and Sony together to kind of profit and market the CD itself. And then this was the first CD player that was created in the mid 80s, which would be able to play audio during that time. And in this video, it kind of basically summarized how the CD was made and how it was produced and marketed, showing just how compact discs were being created during this time. And basically, after the CD was created, it would be able to go to the conveyor belt, being packaged, processed, so it could be sent and shipped out to the market to be profited, so the public could be able to purchase it. And finally, we will talk about the audiophiles and media devices that we have. Does anybody know any sorts of media devices?
MP3 players.
Okay, MC3 player,
Phones.
phone, iPod, sure. Anything else?
Computers.
Computer, definitely. Anybody else? Okay. Well, those were some of the basic ones. We also forgot the CD player, the radio, we also had speakers, and we even had the iPad as well, and other sorts of Apple products. So this is showing just a chart of the evolutionized Apple products that we had over the past couple of decades, including the very first iPod that came out during the early 2000s. That was the very first one, and we kind of continued updating and revising the iPod so it could become more developed and more enhanced for the public to have. And the current ones that we have are the iPhone or the iPod Generation 6, but they're also coming out with the latest Generation 7 coming up. And we also have the iPad Mini, iPad Mini 2, iPad Air, and they also came out with the Apple Watch and other sorts of accessories like that. And these were just some of the audio software that were developed and made by Apple, Spotify, and other sorts of multimedia companies that were developed and created. And showing that, again, reviewing back from the beginning, computers have integrated sound cards that were made and that are inside the motherboard, or again, can be able to use to kind of install or upgrade if you need to for that specific design on the computer. And this is just kind of showing a chart of the different audio file format that we have. So there were 3 categories for that, showing how each compression or uncompressed file formats work. So the first one we have is uncompressed file, which is basically use sound waves and convert them to digital sound. The first one that we had was PCM audio sound, which basically shows which is called a pulse code modulation, digital representation of raw audio analog signal, and it exists in waveforms. And then you have the wave audio format or waveform, which is also an older type of audio file that was contained holding multiple uncompressed files, and showing the last one, which is a AIFF or audio interchange file, which basically is like the wave, except it's a container full of uncompressed files that were used for Mac systems. And then you have loss compression files, which show MP3, AAC, and MWA format, and basically all of them show the same sorts of quality and sound for each other. Each one of them just had different qualities and different functionalities. And the last one we have is lossless compression files, which show the reduced file size without moving data towards specific audio files or compressed. So that concludes my presentation. I hope everybody enjoyed it, and that would be it.